Hey everyone, welcome back to another Master Inspector Explainer. Today, we're treating the Canadian Electrical Code like a high-stakes puzzle. I am seriously thrilled you're here because we're taking on a highly specific but literally absolutely crucial topic that trips up so many candidates on the 309A exam. We're talking about cellular floor wiring rules. You know, this isn't just about rote memorization of some random number. It's really about understanding the physics and the safety principles driving the code. We're going to dive deep into conductor fill limits, heat dissipation, and exactly why these rules are written the way they are. So grab your codebook, get focused, and let's decode this whole thing together. All right, let's jump right into the exact question we're tackling today. And I'm going to read this word for word, exactly as you might see it pop up on your test. What is the maximum allowable percent of the cross-sectional area of a cellular floor that can be used for signal and/or control conductors? Okay, let's look at our options. Is it A, 20%, maybe B, 30%, C, 40%, or D, 50%? I want you to keep this specific question locked in your mind right now. Remember, we're dealing specifically with signal and control conductors, and we are working inside a cellular floor environment. So we're going to break down the code on this right now. And as a master inspector, I can tell you that the difference between a pass and a fail, well, it often comes down to knowing how to navigate the specific terminology of the code, rather than just guessing. So let's figure out the answer together by building up our foundational knowledge first. Oh, and hey, if you're serious about getting licensed, definitely hit that like button and subscribe for more daily sample questions just like this one. Okay, first things first, let's define our terms. Before we can solve the puzzle, we have to really understand our environment. According to the code, a cellular floor is an assembly of cellular metal or cellular concrete floor members. Now, these aren't just your standard solid concrete slabs. They actually consist of units with hollow spaces, which we call cells, that are perfectly suitable for use as raceways. And here's the kicker. Unlike standard underfloor raceways, these cellular floors actually form a structural part of the building itself. The axis of these hollow cells runs parallel to the longitudinal axis of the floor members. And because they're literally holding the building up, Rule 12-1800 mandates they must be installed exactly in accordance with the manufacturer's instructions. This is a highly integrated wiring environment we're dealing with here.
Now, just look at the massive difference here between an overcrowded cell just choking on cables compared to a super clean, code-compliant arrangement. Signal and control conductors, like your Class 1 or Class 2 circuits, they absolutely need physical space. Rule 12-1802 strictly dictates that, generally speaking, you cannot mix different systems in the exact same cell. Jamming way too many cables into a hollow header, yeah, that creates a massive physical choke point. It makes maintenance virtually impossible and introduces some really severe safety hazards. So when you see floor wiring code rules pop up on the 309A exam, I want you to use this three-step master inspector breakdown to calculate your fill limit. Step 1. Always identify the raceway type. Ask yourself, is it a standard underfloor raceway, a wireway, or is it a cellular floor? Obviously, today, we're looking at cellular floors. Step 2. Determine the aggregate cross-sectional area of all the insulated and bare conductors you're actually planning to install. You're going to use the tables in the code for this, specifically tables 10A to 10D. And finally, Step 3. Apply the maximum percentage rule for that specific raceway. You basically multiply the total interior area of the header feeding the cells by the allowed percentage to make sure your conductor area doesn't go over that limit. It's a very systematic process, completely designed to keep the installation safe.
Now, you got to remember, the code isn't just throwing arbitrary numbers at us for fun. It all comes back to rule force 04, which is ampacity. Think about it. When current flows, temperature naturally increases, right? If you pack way too many conductors into a closed cellular floor, all that heat gets trapped. There's nowhere for it to go. This rising temperature absolutely destroys insulation, it risks dangerous electrical fires, and it causes constant nuisance tripping of sensitive circuit breakers. So this area limit, it is fundamentally a thermal management rule. All right, here is your inspector's pro tip out in the field. Strictly limiting your conductor cross-sectional area actually prevents crippling electromagnetic interference, or EMI. We're talking about signal and control conductors today, right? These are often super-sensitive circuits directing the performance of devices or supplying recognizable signals. If you overload a cellular floor near the headers and you accidentally mix high-power supply conductors with these delicate signal wires without adequate spacing or shielding, well, the magnetic fields from the power lines can actually induce voltages right into the signal lines. Maintaining these strict cross-sectional area limits ensures there's enough physical airspace within the cell for proper organization. It prevents this interference entirely, and honestly, it makes it a million times easier to pull or add cables later on. Okay, let's see how all of this builds directly into the answer for our exam question. Circling right back to our challenge, what is the maximum allowable percent? Well, if we open our codebook to Section 12, specifically Rule 12-1806, Subrule 1, it lays it out perfectly. It dictates that where a cellular floor contains cables, other than specific types like mineral insulated or armored cable, the aggregate cross-sectional area of the insulated conductors, bare conductors, and cables shall not exceed 40% of the interior area of the header feeding those individual cells. Therefore, option C, 40%, is the only safe, code-compliant, and correct answer. That remaining 60% of empty space, that is absolutely critical for the heat dissipation and mechanical clearance we were just talking about.
So as you continue prepping for your exam, always remember to look past the raw numbers and understand the why behind them, the heat, the safety, and the physical space requirements. Don't leave your license to chance, guys. Head over to everdash.com for full 309A prep courses, way deeper dives into the Canadian electrical code, and literally hundreds of practice examples just like this one. Get it done right the first time, keep those raceways code compliant, and I'll see you out in the field. But it kind of leaves you wondering, if a simple 40% limit is all that stands between a perfectly safe floor and a hidden fire hazard, what other critical, invisible limits are hiding right beneath your feet?
For more sample question, follow us.